The dependency inversion principle states that high-level modules should not depend on low-level modules. Both should depend on abstractions. So dependency inversion is the strategy of depending upon interfaces or abstract classes rather than upon concrete classes. This principle promotes decoupling between modules and promotes the use of interfaces or abstract classes to define dependencies, allowing for more flexible and testable code. So this probably doesn't make any sense whatsoever, so we're going to start with an example that first violates the dependency inversion principle, and then we are going to correct it. So first of all, I'm going to create an engine class. And the engine class is just going to contain a single method called start, which is just going to log engine started. Okay, and then we're going to create a car class. And car is going to be built up from different parts, and one of those parts is an engine. A car, of course, would also have wheels and a chassis and all different other things that it would be built up from, but we're just going to keep things simple for now and just include the engine. And we're going to have a constructor for this car, and in the constructor we're just going to set the engine, so we'll just say this.engine equals new engine. So we have this car class which has a direct dependency on this concrete engine class, and this car class is also going to contain a method for starting the car. And to start the car we actually need to start the engine, so we can call engine.start, and we can just log car started. Okay, so in this example the car class directly creates an instance of the engine class, leading to a tight coupling between car and engine. So if this particular engine class changes, it may affect the car class, which violates the dependency inversion principle. So if I just show you the UML diagram, what we have here, we have a car class which depends directly on a concrete engine class. Okay, so let's go back here. So how can we fix this issue? Well, first of all, let me just discuss what the issues with this solution are. So if we change the engine class, then it could break the car class. Okay, so that's a problem. If we change the implementation details of this engine class, it can affect the car class. And another thing is that this code isn't very flexible. So if we go into program.cs and we create a car, that's not the correct one. Let's see. Okay. We actually have no way, when we create a new car, we have no way of changing the type of engine that car is built with. So currently, if we want to change the type of engine, so say currently we only have one engine class, but say we have another class called electric engine, or I don't know, V6 engine, or some other powerful engine. There's no way of changing the engine type when we create a new car. You know, we can't just add the engine in here. We have to change it within the car class. Okay, so this isn't very flexible. So if we wanted to say electric engine, we would have to come in here and change it to electric engine, and obviously we would need to create that class. So this is not a very flexible or maintainable solution, because we're having to modify existing source code in order to change the type of engine that a car uses. So this isn't very good. So we can fix this to adhere to the dependency inversion principle. We can introduce an abstraction or an interface between car and engine, allowing car to depend on an abstraction instead of a concrete implementation. So let's come into our folder and create an interface called iEngine, and in here we're going to say that all engines should have a start method. Then inside of our engine class, we can say that engine implements iEngine. Okay, so an engine is an engine, obviously, and we don't need to do anything here because our engine class already has a start method. And then in car, so currently we have car depending on the concrete implementation of an engine rather than an abstraction such as an interface or an abstract class. So let's change this, so we can say that rather than engine being this concrete engine, we can say the engine is some type of engine, some abstract engine. And then within the car constructor, we can actually pass a type of engine that we want the car to be built with. So we can say this.engine equals engine. Okay? So the advantage of this method is that it provides us with a lot more flexibility, because now whenever we create a new car, we can at runtime we can pass in what type of engine that we want the car to be built with, like so. And currently we only have one type of engine, but let's just say we also had another type of engine that implements the iEngine interface, such as electric engine. Then we can create some sort of electric car. We can build this car up with an electric engine. Okay, so this is called dependency injection, where we inject the dependency into the class. Okay, and this is a very popular term that you may have heard before. Frameworks such as Laravel or Spring Boot use dependency injection throughout a lot of the framework. So let me show you the UML, so what this looks like. So beforehand we had car, which directly depended on engine, whereas now we've added this kind of abstraction, this interface between car and engine. So car now depends on this abstract engine interface, and engine implements the engine interface. Okay, so now we can create multiple different types of engines, each implementing this interface. So we could have a V6 engine which implements this engine interface, or an electric engine, and we can then inject that engine whenever we create a new car object into car to be built with that type of engine. So this has really improved the flexibility of our program. So a few advantages that I just want to mention of dependency injection are that dependency injection promotes loose coupling between components by removing direct dependencies, so that components rely on abstractions rather than concrete implementations, making them more independent and easier to maintain. And dependency injection simplifies unit testing by allowing components to be easily replaced with mock or stub implementations during testing. This enables isolated testing of individual components without relying on their dependencies, and as we discussed, it improves flexibility because we can swap out dependencies at runtime. And then one more thing that I just wanted to mention. So if we go to the dependency inversion principle definition, it states that high-level modules should not depend on low-level modules. Both should depend on abstractions. So we saw that car and engine are now depending on abstraction, the iEngine interface, rather than on each other. But which of these is the high-level module and which is the low-level module? So the engine is actually considered the low-level module, or the low-level abstraction, because it deals with specific detailed operations related to power generation, whereas the car, in this case, would be considered the higher level abstraction or the higher level module, because it encompasses a broader scope, coordinating multiple components, including the engine. So currently we only have the engine, but in a real car would of course have multiple components, and to deliver the overall functionality of the vehicle. So the car is the higher level module and the engine is the lower level module, and the high level module no longer depends on the low level module. They both depend on an abstraction, and therefore our code is much more flexible and much more testable, easier to maintain, and that is due to the dependency inversion principle.